Hi students, coming to the next topic, that is memory organization. Now let us see how the memory is organized in the operating system. A memory can be organized in different ways. One process uses entire memory space. One process uses the entire memory space, and each process gets its own partition in memory, or else each process gets its own partition in memory. So that may be dynamically or statically allocated. Dynamically or statically allocated. So the name itself is indicating memory organization, how the memory is organized in the main memory. So whatever the main memory you are taken, okay, so that main memory, how the data is organized, whatever the data that we are sending, whatever the process operation means, the process you are taking, that has to store in the main memory. So one field is stored in operating system, and the remaining will store all the processes. So here the memory can be organized in different ways. One way is one process uses entire memory space. So the remaining entire memory space used by one process, or else each process, suppose this is an operating system, it is divided into different chunks. So each process gets its own partition memory that may be allocated dynamically or statistically. So this is how the memory is organized. The memory is divided into, so whatever the memory here, so that memory is divided into types. So that may be a main memory, and next secondary memory, secondary storage memory. So the complete memory organization is divided into two: main memory, secondary storage memory. Main memory is nothing but the RAM, random access memory, and the secondary storage memory is a disk. So this is RAM or ROM, and this is disk. So you take ROM or ROM. So the main memory is, when compared to the second memory, main memory is relatively expensive and relatively having small capacity. It can store only the little amount of data. So this is small capacity when compared to secondary memory. And high performance. The performance is high because it is a very fastest storage device when compared to the secondary memory. Main memory is having the fastest storage. Coming to the secondary storage memory. So that is this. So this is cheap when compared to main memory. The cost of the secondary storage is cheap, and it is having the large capacity. It can store large amount of data, and it is slow when compared to, the performance is slow when compared to the main memory. So here the main memory requires careful management. So everything we have to done, the memory organization will be done on main memory. So the secondary memory storage means you can erase if you want, you can erase, you can use whenever you required. So there is no frequent access to the secondary storage memory. Only the frequent access will be done in the main memory. So while doing the memory organization in the operating system or in the computer, we require a careful management on the main memory. Now let us see the memory management. Let's see the memory management. The memory management here, the strategies for obtaining optimal memory performance can be obtained. The optimal memory performance. How can we manage the memory? So based on the performance of the different memories that we are using, the optimal memory performance can be obtained performed by memory manager. So the memory manager can be performed to get the optimal memory performance. That is, he has to think about which process will stay in memory. So he has to check the memory management. The memory manager has to check which process will stay in memory. Means to maintain the memory management, the memory manager has to perform some task. So these are the tasks that he has to check. The memory manager has to check. So which process will stay in memory? How much memory will each process have access to? So he has to check, the memory manager has to check how much memory will each process have access to, and where in memory will each process go. So where this process will store, in which memory, in which chunk, and in which task these process will store, where in memory will each process go. So these are the necessary statements that the memory manager has to perform. He has to check whether which process will stay in memory, how much memory will each process required, and each process in which storage location it is going to be stored. So that will be, everything will is a calculation of memory management. Okay. So this is just an introduction of memory organization and the memory management. Thank you.